So as we're discussing in this particular topic of overlap save and overlap add method for convolution, we are basically dealing with a scheme where this method will be used for convolution of extremely long sequences. Now when we speak about extremely long sequences, we mean by the fact that a physical signal, if it is sampled at a very high sampling rate, there could be numerous samples, much unlike what we have been dealing with right now. Probably we have dealt with signals of length 4 or 3 in various operations that we have done. So in practical scenario, when we have signals of extremely large length, it is very important to focus or learn about this overlap add or save method, primarily because of the fact that convolution of such extremely long sequences would be time consuming, and we need a more efficient solution for that. Hence we are preferring overlap save and add method, where we are breaking down the sequence to obtain the desired output of this convolution. So we have a particular case over here as shown in the table over there. You have a sequence of length basically 12. You can see that this particular sequence 1 is of length 12, and it will be from the position 0 to 11. So 1 2 minus 1 2 3 minus 2 minus 3 minus 1 1 1 2 minus 1. This is sequence 1, and you are expecting it to be convolved with another sequence which is highlighted with sequence 2, which is of length 1 2 3. And now the convolution result you expect to come out will be like 1 4 6 6 4 10 2 minus 13 minus 10 0 7 6 4 and minus 3. This you could verify with the tabular method for linear convolution, and you can see that that is the desired output. And also you can see here that sequence 1 is of length 12 and sequence 2 is of length 3. So output of the linear convolution should be equal to 12 plus 3 minus 1, that is 15 minus 1 equal to 14, and hence you can see that the output here spans from 0 to 13. There will be 14 samples ranging from n0 to 13, and you can see that this is a convolution result. And we are going to see the overlap save and overlap add method by which you can perform this particular convolution. Before learning how to solve this problem with overlap save and add method, we are going to assume three variables over here which will be given by L, M and N. Now what is going to happen here is M is going to be the length of the shorter sequence. So here the shorter sequence is of length 3. So I'm assuming or taking my M to be equal to 3. And you can see that there are two variables L, and there is another one variable N which is to be decided or to be approximated. So I'm going to take up a concept where N is assumed to be greater than M. Mind you, it is not greater than or equal to M, but N we assume it should be greater than M. So you can do this problem in any way by assuming a value of N, M and L. So what I'm doing right now is just one of the approximations. There are many ways that you can do this for a particular problem, but this logic can be followed. So N is greater than M. So here, since M is equal to 3, we take N to be equal to 4. So let N be equal to 4, and I'll explain what N and L will become when in terms with the explanation as follows. Now we need to determine the value of L. So N, the relation between these three variables can be guided by this equation. N will be equal to L plus M minus 1. So with so we need to determine L. So L will be equal to N minus M plus 1. So we have N equal to 4, we have M equal to 3 plus 1, making L equal to 2. So we have got we needed three variables to be assumed, and we have got their values. So M is the length of the shorter sequence, which is equal to 3, and N and M will be explained right now. So we are going to first explain overlap add method, and then we'll move on to the overlap save method. So to get on with the overlap add method, what we are going to do right now is we are going to break down the sequence. Like I mentioned before to you, this is also known as sectioned convolution, where you are going to break down the sequence that are to be convolved into shorter sequence and perform individual convolutions to obtain the ultimate result of the linear convolution. So I'm going to break down these sequences. Now, how do I break down? This concept has to be understood first. So my sequence here is as follows. You have 1, 2, minus 1, 2, 3, minus 2, 3, minus 3, minus 1, 1, 2, minus 1, which is a sequence 1 that I have over here. How do I break down the sequence? I have two components to be taken care of over here. One is L and other is N. So with L equal to 2 and N equal to 4, I'll be showing you how it is relevant for this particular problem. So what I do here is I break down the sequence into components of length equal to 2. So this will be my first part, which is of length 2. The next part will be here between these two. The next part will be here between these two. The next will be here. The next will be here. And the next will be here. So I have divided my components or the original sequence into sequences of length L. So you can see here that the first component will contain 1, 2, minus 1, 2, 3, minus 2, minus 3, minus 1, 1, 1, and 2, minus 1. What I ultimately need to do is I need to create a sequence of length n out of these two components. So if you know over here, you can see this particular concept that a sequence of length n will contain two components, one which is of length L and other which is of length m minus 1, which will be equal to 3 minus 1 equal to 2. So as you look over here, your sequence of length n will contain a sequence, or will actually be a sequence of length 4, out of which the two components are of length L. So what I need to do here is I create a sequence of length n out of this 1 and 2, whereby I get it as 1, 2, 0, 0, where this 0, 0 is equivalent to the m minus 1 components to make it of length n. So if you look over here, the sequence is of length n. What will be the next sequence? It will be minus 1, 2, 0, 0. Then it will be 3 minus 2, 0, 0. Then it will be minus 3 minus 1, 0, 0. Then it will be 1, 1, 0, 0. Then it will be 2 minus 1, 0, 0. So I have broken down my sequence into length of L, and from them I have created a sequence of length n, as you see over here. 1, 2, 0, 0, minus 1, 2, 0, 0, 3 minus 2, 0, 0, etc. So I have created such sequences out here. So what I need to do now is I need to perform the circular convolution of this sequence with the one that I have in the form of sequence 2. So let me put it before you. So I'm going to perform right now the circular convolution of this particular sequence 1, 2, 0, 0 with 1, 2, 3, 0, which means I have to complete this matrix. This will be like 0, 1, 2, 0. Then it will be like 0, 0, 1, 2. Then it will be like 2, 0, 0, 1, and it has to be multiplied with the matrix, which will be 1, 2, 3, 0. So ultimately when I do this, I have to operate on the matrix. So it will be like 1 followed by 2 plus 2 followed by 6, not 6, it's 4 plus 3, and then it will become 2.3. So the matrix, it becomes 1, 4, 7, 6. So what I did right now is I performed circular convolution between this sequence 1, 2, 0, 0 and 1, 2, 3, 0. Now to perform circular convolution, both of them must be of the same length, which is why I zero padded this 0 over here. Just like what we just did over here, what I did next is I performed the circular convolution between this sequence -1200 with the sequence 1230, and I get the result as -1016. Again, if you look over here, it's the same operation that is performed. 1 into -1 is -1, and rest of them will be 0. 2 into 1 is 2, -2 into -2, -1 into 2 is -2, then it becomes 0, 4 and -3, 0, 0, then 6 and 0. So it becomes -1016. Now what we need to do is we need to perform the individual convolutions as we had done the first and the second over here, and then you will get the results like 1476 -1016, 345 -6, -3 -7 -11 -3, 1353 and 234 -3. So this will be the result of the circular convolutions when you perform the individual circular convolution with the sequence 1230. So you have 6 sequences over here, so you have 6 results too. Now when you come to this particular block that I'm going to explain right now, this should give you an idea about what is happening in this scenario. So this is how we divided the data. We had 1200, then -1200. So these are the blocks of data into which we divided the original sequence 1 into, and then we get the results of the convolution. Now this results of the convolution should be written in the same positions. So for the result of convolution 1, it should be starting from 0. So we started from 0 and we have written it down. The result of the circular convolution of the second sequence should begin from the position where it was created. So the position is 2 and it is written at 2, -1016. Similarly, you can see how these sequences are written: 3, 4, 5, -6, -3, 7, -7, -11, -3, 1, 3, 5, 3, and 2, 3, 4, 3. Now, since this is the overlap add method, as the name suggests, we will be adding the overlapping elements. So at the position 0, we have no overlapping, so it can be added and it comes straight to 1. At 1 also there is no overlapping, so you have 4. At position 2, you have 7 and -1. When you add them, you get 6. Similarly, you get 6, 4, 10, 2, -13, -10, 0, 7, 6, 4, and -3. So this is how you get the result of the circular convolution, and it is exactly the same result as we had got over here. 14664. 14664 is again the result that we have over here. Then you have 410 to -13, 410 to -13, and you can verify the result out over here. So this is how we perform overlap add method, and you could get any long sequence and you can break it down. If you are trying to break it down, make sure that you are getting it in the exact length. There might be cases where you would have a situation where you are not able to break it exactly in the same manner. For example, if you have a sequence of length 13, you will not be able to break into exact sequences of 2. So what would happen here is you will have an extra element at the end, which should be again considered as a 2 element sequence. So you can 0 pad it over there and perform the same operation. Meanwhile, what you could do is if you're given a problem, if you're getting a numerical, what you could do is you could do this particular tabular method and get the result first, and make sure that you're getting the exact result of the tabular method in your overlap add method. Now in that particular case, there might be a missing element. If that is a case, then all you need to do is take an extra sequence and perform the same operation and get the desired output. So I hope this clarifies overlap add method. In the next video we will see overlap save method.